Hello there, this is AI Builds with AJ, and the premise of this video is to discuss the primary architecture styles. So if you see here on the screen, or if you're commuting and you can't see it, that's why I'm going to read this off for you. So typically we have four architecture styles. The first will be the chain of thought, which is a sequential workflow. It is, as you see on the screen, the logic workflow is A, B, and C. It is best for highly structured processes with predictable steps, i.e. the ETL pipeline. Meaning the prior step will affect the post step after the prior step. What am I saying? So if step A fails, you won't get to step B. Or if you do get to step B will also fail because it's dependent on the step prior to it. The router and orchestrator is the central hub. It directs specialized workers. It's best for complex systems where different tasks require different expert tools. I think of a tech recruiting agency. They source talent, and then the companies that's looking for the talent, they direct them. They get the two together for interview process and or they get hired directly. That's what I think of when I think of the router orchestrator architecture. This one is near and dear to me. A lot of the tools that I've built are state machines, deterministic. I don't think we should be relying on LLMs in regards to that they're nothing more than a probabilistic engine, meaning it may give you the correct answer, it may not. It's probabilistic. The logic flow here is explicitly defined states and transitions. It's mission critical systems, finance, and health, where looping or hallucinating is unacceptable. So, like when I was creating Agent Fintel, that would be an example of the state machine. Some of the values were hard coded based off of the industry standards, and then I meshed in some AI to provide some reasoning of the data to make it a little bit more understandable for the user. Multi-agent. Multi-agent collaboration, I think of Crew AI. Crew AI is a framework where there's a multi-agent collaboration. So you have several agents, each agent doing a specialized task. And that's pretty much it. One agent will hand the work off to the other one. That one will complete his task and hand it off, and so on and so forth. So for the multi-agent collaboration, independent agents debating or working in parallel, complex problem solving like software engineering or strategic modeling. So we have three more points here. So you have the autonomous agent, the React framework, which is reason and act. The reason and act framework is the most common pattern. The agent writes down his thoughts, acts, observes the result, and repeats. It is highly flexible, but it can be prone to infinite loops if not governed by strict iteration limit. And that's pretty much the gist of most computer programs where looping is involved. If you don't have a good stopping point or if it's not properly controlled, it will pretty much hallucinate like how we know it now. But looping prior to AI, it would drain a lot of resources and it's very resource intensive. So, and as we know it now, that is called hallucinating because typically agents are just on a looping mechanism, as we just seen here. And looping is just meaning it's doing the same thing over and over. It's almost like a circular motion. So in this instance, the agent writes it down. It writes down its thoughts for what it observed. It acts. It observes the result that what it first initially observed and or thought, and then it repeats. Then you have the plan and execute pattern. This separates the strategist from the executor. A planner agent creates the entire roadmap first, and an executor agent then runs through the steps. This minimizes the risk of the agent getting distracted mid-task. Um, just like when you're designing your systems, it's very important to plan first. Clarity is key. If you don't remember anything, clarity is key. Before anytime I design a system or design an agent or anything, I always consult. Perhaps I will have the idea written down and then I will work out the kinks with a different LLM and then I will provide it to Claude, which is my favorite LLM. I'm a developer, so naturally, Claude is my favorite. So plan and then execute. This will minimize a lot of the issues in regards to hallucinating and just burning up memory and things like that and tokens. Hierarchical, hierarchical architectures. In this model, a lead agent oversees several sub-agents. The lead doesn't do the work, it merely validates the work of the specialist. This mimics a traditional management structure and is highly scalable for enterprise applications. And this is just as the last sentence says, this mimics a traditional management structure and is highly scalable for enterprise applications. This reminds me of the org charts in a typical tech company where you have your data architect, your project manager, your product manager, your engineers, your QAs. Um, it just in a hierarchical architecture, basically. The lead does nothing but validate what the sub agents do. The lead does not do any work. It just validates it. It's almost like a project manager on a construction site. All the guys doing the work, you're just making sure that they have the materials and that they are getting the work done in a timely manner. So that's it for that. But like I said before, the premise of this video was more so educational based, opposed to just showing you guys what I've built. Um, I know I went stir crazy at a point in time in regards to using AI and just all the capabilities that I have based off of these tools. So getting a little theory behind it, a little clarity behind which route you want to take when building these agents. Because I mean, this is the present and the future. So having a good grasp of the understanding of what's going on with these agents. Why does your agent hallucinate? Are you giving it the proper context? Are you feeding it the proper examples? Things like that. Which LLM is specializes in one task that's not as good in the other. Just things like that. A lot of this stuff is out there. I look at these AI tools as like a study buddy. Anything that you want to know, you can pop it in here. Of course, you want to verify it. Always, always, always verify. Test, test, test before you just hang your hat on anything that the engine tells you. I mean, it's a probabilistic engine, so it's not always correct. And I think that's important for everyone that's a little afraid or that just are unaware of AI, or they are aware, but they're frightened that it may take your job. If you just take a peek under the hood, and that's the content I'm about to start providing, more peeks under the hood to make help guys and girls become more comfortable with it, so they don't fear it, but use the powerful tool that it is to leverage themselves to what they deem to be success. So that's enough talking for me. I hope you guys enjoyed this video. This is AI Builds with AJ. Have a blessed day and bye bye.